This is from Chapter 3, problem number 4. We have a situation where we're going to roll 2 fair dice. Each die has 6 faces. And we want to select a sample space. And you're going to consider A as the event that either 3 or 4 is rolled first, followed by an even number. And then event B is the sum of the rolls of the 2 dice is at least 7. I'm going to change this so it doesn't look exactly like your homework. RD in words, explain what P of B and this vertical bar A vertical bar B represents, and then define that. And then here A and B are mutually exclusive events, yes or no, and are they independent? Alright, let's take a look at part A when we're looking for the sample space. Sample space here. For us to do this with dice, we have to realize, and a good way to do this is to make a little table. Realize that there's 2 dice. Each of them has possibility of getting 1, 2, 3, 4, 5, or 6. And so for the sake of this particular problem, it's nice to look at it from a table point of view. And so we can do this in a couple ways. One, we can say this is the dice roll 1, 1, and this is the dice roll 1, 2, etc. But instead of doing it that way, I'm just going to put the sum down here. And let's just consider this the first die, and then the second die. So the sum would just be 2, and then 3, 4, 5, 6, 7, etc. So we can just fill in the rest of this table. Okay, so now that the table is set up, we can look at this body of the table as our sample space. And so this could be the combination. But remember, the actual sample space might look like this. So 1, 1, that's for this first one. 1, 2, 1, 3, etc. And then 2, 1, 2, 2, 2, 3, and so on. So that's the whole sample space. Sometimes, more importantly, the amount in the sample space is more important, and so amount in sample space is going to be, well, there's 6 in one row, 6 in the columns, and so this is a 6 by 6. We'll have a total of 36 possibilities. So that's our sample space. Alright, let's take a look at event A, and I'm going to use a highlighter here to highlight some things in event A. Event A is either 3 or 4 rolled first, followed by an even number. So 3 or 4 rolled first, followed by an even number. So this even number 2, 4, and 6. So these, I guess, I don't know, maybe I shouldn't have highlighted the 3 and 4 on the outside. So these combos are going to be your event A. So let's see if we can list that down. Event A is going to be equal to the list of 3, 2, 3, 4, 3, 6, and 4, 2, 4, 4, and 4, 6. So that's the event A. And notice that there's 6 of them. You can see that by the highlights. And so the probability of event A happening is going to be, there's going to be 6 of them out of a total of 36. Okay, that's event A. Let's see, event B, this is B, C, this is A here. Event C is going to be event B, sorry. Event B is going to be the event that the sum of the two rolls is at least 7. So we're looking at 7 or greater. So let's see if we can figure that out. Let's pick a different color highlighter here. Let's do green. The values of 7 or greater. So 7 and greater. So all the rest of this stuff here. This looks like it's quite a bit to write. So I'm not going to write the actual event space, but let's write down a couple. This combination of 1 and 6 makes a 7. The combination of 2 and 5 makes a 7. The combination of 2 and 6 makes 8, which is at least 7, bigger than 7. Oh, sorry, 2 and 6. And then we'll keep going on forever here. Well, not forever, but at least these green highlighted. The more important part in this problem is to figure out of all the 36 possibilities, how many of these are highlighted green. So 15, 21. Alright. Part D. In words, explain P of A given B. So this is the probability that we roll the event A, that we roll a 3 or 4 with even number so that's a probability of event A. This is event A right here, given that the roll was event B is at least 7, was at least 7. So what we want to do for this particular problem is that we want to look at all the events, all the possible event B, and out of all those possible events in B, how many of them would fall under event A. Let's see if that made sense. Well, they actually want us to compute probability of A given B, and the way we would think about doing that is, let's take a look at the number of values in our B event. So that would be 21 of them. And out of those 21 possibilities, how many of them were highlighted as event A's? So I think 5, 6, this 5, this 6, this 7, this 8, this 9, and this 10. So 5 and 6 were not part of that set, but 7, 8, 9, 10, this 7, this 8, this 9, and this 10 were. And so there's 4. There's 4 of those that look like we would be interested in. Uh-oh. Alright, so there's 4 of those events. So out of all number in B, event B, and this is number of event A's that live in that are also in B. So that is what we want to look for. And so there's it's 4 out of 21. Okay. Now the last two problems are A and B mutually exclusive events. Mutually exclusive means they don't intersect. And clearly there are these numbers in yellow where they are both in event A and event B. So I'd have to say that A and B are not mutually exclusive. And to show information about mutually exclusive, we can say that there is an overlap. You can say event, let's see, this 7 is a 3 and a 4. So 3, 4 is an element in our sample space, is in event A because it's rolling a 3 first and then rolling an even number, and it is also in event B because the sum of that dice roll is at least 7. So because there is at least one thing in common with A and B, then we have to say that they're not mutually exclusive. Okay. For F, are they independent events? I would have to say that they are independent. A and B are independent because when you roll 2 dice, rolling 2 dice, and then rolling 2 dice again will give you different results. And the second time you roll the 2 dice is not going to depend on what happened in the first time. It's not dependent on what happened in the first time. Will be independent of the first dice roll. So I think they should be independent in that case. Alright, so that is question number 4 in chapter 3.